What's up, everybody? My name is Dana Harris with Young Gurus Math Tutoring, and I'm back again to drop some more math jewels. In this video, I want to show you how to solve systems of equations using substitution. All right, let's get right into the examples. Example 1, we have a system of equations, and you'll see them in different ways. So I'm going to write this one here. X plus y equals 8, and y equals 3x. Sometimes you may see them listed just like this, or you may see them with this symbol like that. Same thing is just showing you that it's a system of equations. Now, when we talk about solving them by substitution, what we're going to do is we're going to substitute one value of the variable into the other equation. So right here you see y is already solved for. So y is equal to 3x. So what we're going to do is we're going to actually substitute 3x into the first equation for y. So what I'm going to do is I'm going to rewrite the first equation. So I'm going to say x plus, now y equals 3x. So I'm going to put 3x right there. And I like to put, anytime that I'm substituting for a variable, I like to put it in parentheses. It's just a habit that I have. Now we're going to solve for x. So x plus 3x equals 4x. And 4x is equal to 8. From here, I simply divide by 4 on both sides. And then those cancel, and I get x is equal to 2. Now that I have the value of x, I can plug that back into the other equation. And you can do it in either one. It doesn't matter. But I always plug it back into the other equation. So I'm going to take this and plug that right there. So I have y equals 3 times 2. All right, so 3 times 2 is 6. So now I have x equals 2, y equals 6. Now remember, your solution is the ordered pair 2, 6, because what happens is in a system of equations, the solution that we're finding is just we're trying to determine where do those lines intersect. So this is the equation of a line, this is the equation of a line. And our solution is where these two lines intersect. That's the goal of solving a system of equations. So in example 2, I have x plus 3 equals y. And then I have 3x plus 4y equals 7. And once again, that's that difficult sign that's hard for people to draw. So notice y is already solved for. So if x plus 3 equals y, that's the same thing as saying y equals x plus 3. So I'm going to substitute that into this equation right here. So I'm going to say 3x, or 3x as I like to say, plus 4 times x plus 3 equals 7. So all I'm doing is rewriting this equation, 3x plus 4, and then I substitute x plus 3 for y, because it's y is equal to x plus 3. And then now I'm just going to solve. So I need to distribute there. So I have 3x plus 4x plus 12 by the distributive property equals 7. Combine these, I get 7x plus 12 equals 7. Subtract 12 from both sides to get the like terms together. Those cancel. I get 7x is equal to 7 minus 12 is negative 5. Divide by 7, and x is equal to negative 5 over 7. All right. So now I have my value of x. Now I need to plug that into the other equation. And as you can see, there's a fraction, so it's going to get kind of tricky. But it's okay. So I'm going to say negative 5 over 7 plus 3 equals y. Okay, I just took this value of x and plugged it into the first equation. Well, in order to add those, I have to get like terms, or a common denominator actually. So negative 5 over 7 plus 21 over 7. Remember, 21 divided by 7 is still 3. And that equals y. Well, 21, or negative 5 plus 21 is 16. So 16 over 7 equals y. So now I have my x, I have my y. So that means that my solution is negative 5 over 7 and 16 over 7. Once again, your solution is always going to be an ordered pair. So just because we solve for x and we solve for y, that tells us the coordinates, the x coordinate and the y coordinate. Our answer is going to be a ordered pair. All right, let's look at another example. Get this cleared off, and we will go to, let's do 2 more examples because I like to try to give a variety of examples that you may see if you're doing this type of stuff in the classroom or whatnot. Example tree. We have, this one is going to be a little more tedious because in this example, we're going to actually have to solve for the variable. Okay? So in this one, I have 4x equals 3y minus 2. And then I have 18 equals 3x plus y. All right, so in this case, now what I have to do is I actually have to solve for one of those variables. Now, I'm choosing to go with let's go with, it doesn't matter. It's up to you, but I'm going to go with this second one. So if I have 18 equals 3x plus y, my number sense tells me that I can actually get y by itself by just moving the x to the left side. So I'm going to subtract 3x from both sides. So this gives me negative 3x plus 18 equals y. Okay, so now I have solved for y, but I've got to plug this expression into the other one. So what I'm going to say is I'm going to say 4x equals 3 times negative 3x plus 18 and then minus 2. Okay, so I rewrote this equation, 4x equals 3y minus 2, but instead of using y, I use negative 3x plus 18 because that's the value of y. So I have 4x equals, distribute here, so negative 9x, 18 times 3 is 54. Yeah, 54 and then minus 2. Okay, so now that I have that, we can combine like terms. So 4x equals negative 9x. 54 minus 2 is 52. And then now I'm going to take this x to the other side. So plus 9x plus 9x. And then 13x equals 52, because those cancel. And then divide by 13, divide by 13. X equals 4. All right, we're still not done. Now we have to take and substitute in this x to one of the other equations so that we can finally get our solution. Now, I'm going to be kind of all over the board this time because I want to make sure that we show this. Well, let's go back over here. All right, so let's say I have, since I have x is 4, so let's do the other one. 18 equals 3 times 4 plus y. All right, well, 18 equals 12 plus y. Subtract 12, subtract 12, 6 equal y. Okay, I have my x, I have my y. So my final solution is the ordered pair 4, 6. That means that these two equations, if I graph them, they will intersect at the ordered pair 4, 6. So example 4, we have another one. Now, I think it's easier to solve for y here, so I'm going to say y minus 2x equals tree. I'm going to add 2x to both sides, and then I'm going to say y equals, I could say 3 plus 2x, or I could say 2x plus 3. It doesn't matter. But I'm going to take this and substitute this into the other equation, okay? Also, remember, whenever you have to solve for one of those variables, whichever one I use to isolate the variable, I have to substitute that value into the other equation. That's very important, okay? Or else you won't get the correct answer. So if I have 3x minus 2 times 3 plus 2x equals 5. So 3x I need to distribute here. So 3x minus 6 minus 4x equal 5. Well, combine like terms. 3x minus 4x is negative x minus 6 equal 5. I add 6 to that side, or both sides rather. Negative x equals 11. So this is like saying the opposite of x equals 11. So you could do two things. You could divide by negative 1 on both sides, or you can just kind of flip the signs. So I like to just say divide by negative 1 because technically that is a coefficient of 1. So those negatives cancel, so x equals negative 11. Now that I have my x value, I can plug in my y value back into the other equation. I'm sorry, my x. So I can say y minus 2 times negative 11 equals 3. So y plus 22 equals 3 minus 22 minus 22. That gives me y equals negative 19. So my ordered pair for my solution is negative 11, negative 19. And always remember, these systems of equations, whenever we solve them, you can plug back in this x and y value into both equations and it should calculate out to equal the same value on both sides. So for example, if I say negative 19 minus 2 times negative 11, negative 19 minus 2 times negative 11 is 22. So negative 19 plus 22 does equal 3. All right. Thank you so much for watching these videos. Please subscribe to the YouTube channel. Like and share with a friend or anyone you know that could use this information. I appreciate everyone for your support. And once again, Young Gurus Math Tutoring. I've got the solution to your math problems.